Hey folks, Segasonicfan here, and I just repaired this tube amplifier. This is the kind of music you should really listen to when you're doing tube amps. Not a lot of stuff is meant for tubes. Well, I should say a fair amount of stuff. Some stuff is not as much. A lot of modern electronica synth stuff doesn't sound that great with tubes. But old crooning songs sounds wonderful, as does some classic rock. Anyway, on to the repair. Someone gave me this like super jacked up, filthy, missing screws with like tape all over the place. 13194, if you can see the model number down there. This is a Monoprice hybrid tube and Class AB. They call it Class AB. I don't actually think it is. Amplifier, and it's interesting. It's a mix of like kind of cool, kind of jank. I got it for free, so I'm not going to complain. But do I think this is worth $100? Heck no. Which I think is what MSRP is for, $109. No. There's much better options out there. In fact, I would just recommend getting one of these small little tube things you can get, like these guys, which are like $30-40, and will give you the same effect. You just hook it up to a regular amp. But we'll see. I mean, I just fixed it, so I have to put some time into it to give it a thorough review. But as you can see, someone actually was in here before. Ooh, let me make sure to unplug the mains before I start poking around. So, yeah, by the way, if you're going to do main stuff, always make sure to have an isolation transformer, which has a fuse built in. And that goes to this guy, so I don't electrocute myself. Safety first. I just unplugged everything. You can see whoever was in here before had taped these amplifiers down to the frame. There's a bunch of other tape in here. This poor bastard did not know how to fix this. I feel bad. Someone really tried. And the symptom, I'll start off with the symptom. You should always start off with the symptom. Loud buzzing coming from this channel. Which, what channel is that? That is the right channel. And everything else actually seemed to work fine, aside from that loud buzzing. So this person sort of thought, well, if I replace the two amplifiers, that'll fix it. And of course it did not. If you're, word of the wise, if you're getting a loud buzzing sound, it means that your amplitude gain is probably working. All these are doing is they're basically high-powered op amps. They're just amplifying the audio signal. If there's no signal there, they're still going to amplify whatever they can. What did the problem turn out to actually be? Surprise, surprise, a capacitor. This 4.7 microfarad capacitor, to be exact. I'm going to see if I can get slightly better lighting here somehow. This guy, which was not surprisingly sandwiched between this larger capacitor and this heatsink. So, probably getting hotter than it should. Also, it's a really, really cheap capacitor. As you can tell, most things inside of here are really, really cheap. This is meant for budget people that can't really afford nice high-end tube stuff. And that's what this whole thing is about. It's about budget tube sound at a budget price from a budget company. So don't expect too much. But, could be worse, could be worse. We got our single-sided PCB, bridge rectifier, split power supply. The amps they're using are okay. They're classic gain clone amps. They're LM1275s. God, I used these like 15 years ago in projects. These are classic. Oh, sorry, 1875. Gosh, brain fart. Yeah, the LM1875. Yeah, it's a nice little 20-watt amplifier, 20 watt per channel. Of course, the 20-watt reading is probably dependent on total harmonic distortion plus noise, which is probably at that amount, maybe 1 to 10%. I don't know. I didn't look at the chart yet. I haven't looked at the charts for those in years. But it's a decent sound. You got two decent amps. And of course, what you're really paying for, though, is the preamp stage, which uses these tubes. And the preamp stage, it's nothing to get too excited about. They have JRC 4558s, really standard kind of stuff, cheapo capacitors. They did use some of the nicer ones over here for the amp stage, but not for the preamp stage, which I don't know why, but so it goes. I guess there's some of the preamp over here. Yeah. And anyway, yeah, I replaced that capacitor. Everything was fine, but I figured I'd show you all a little bit of my reasoning behind that, since the capacitor was not totally obviously blown, which is why the person who first attempted to fix this did not. What I ended up doing was I undid the four screws that hold this board down, undid these two plugs, and you got to be careful because a lot of these plugs are sharing the same connector, so I actually just left all these plugged in, and I just unplugged this one going to the Bluetooth board. Back here is the Bluetooth, I'm sorry, that's the input board, and the Bluetooth antenna, kind of built in one. So these two cables are actually shared. This one goes directly to the Bluetooth and CD switch up there. But, you know, I flipped this over and just did a quick rundown of like what's going where, you know. And I just thought I'd show my repair process to give people a leg up here. And so the first thing I did, I did a number of things, but let me just start. Like, I think a good way to do this is you find out, of course, which channel is bad. It's the right channel, which went to this red wire right here, which we know plugs into this connector right here on the other side of the board. Big connector, right? Okay. So you got your speaker out connector right here, red, black, red. The black is the shared ground, and the two reds are each channel, left and right, respectively. Those go to this yellow block here, which is a relay. Very common in power amplifiers. You have a relay to switch the load when things are ready. Looking at that relay, I didn't actually need to look up a data sheet. You know, you can oftentimes, it's along the vertical axis of the relay that, you know, it's going to switch. Not going to switch diagonally, usually. But, yeah, I felt like it was pretty sure thing. You can follow these really wide traces, too, to tell what's power and what's not. You know, usually wider traces are going to carry higher current. So here's our, going to this pin right here of the relay. That pin is our speaker output. And so, yeah, you can tell this wide trace here is what that's going to go to when it clicks on. The smaller traces over here going to this smaller plug, that's going to be your, like, probably a 12-volt signal to turn on the relay. And it's going to switch on the 2 amps, right? So you just look for those wide traces. And so in this case, this goes to this pin over here, which clearly is the LM1875 on the left. And that's what I'm really trying to discern, is which amp stage is giving me the problem. Again, I don't think it was the amp, but I have to figure out at least what stage so I can go backwards into the circuit and kind of follow that path, you know, down to the preamp stage if I have to. So I'm looking at this guy, and it's going to be this one that's the problem. It's already been replaced, so I'm not really going to start with replacing it. Plus, it's already amplifying, so I'm not too concerned with that. I pulled up the data sheet, and what I really am going to concerned with is the input. Especially if you're getting amplification, it's likely going to be you want to start with the input. And the input actually runs over, sorry for the shaky camera, but the input is pin 1, which is this pin right here. By the way, 2, 3, 4 looks like the output that's going to the relay. So pin 1 is your input, and again, check out the trace widths. You can see this little skinny trace? That's going to be an audio signal, a low-level audio signal. So let me turn off the light here too. Maybe it might be a little better if I get, about the same, but whatever. So yeah, here's our audio path. Now that audio path goes through a capacitor, and then on down to our preamp stage. However, that's the positive signal. There's also a negative signal, and so for the ground. And the ground is pin 2 here, the negative input to what is essentially a high-powered op amp, the LM1875. And the ground goes to this capacitor, which couples it to ground. And so this capacitor, I looked at it a little more closely, and I was like, couples to ground. It would absolutely give me a buzzing sound if you don't have proper grounding for your amp, of course. And it's close to the heatsink, and yeah, let's give it a shot. So, close to the heatsink is a very common failure for electrolytics because they have liquid inside of them, and that dries out. They fail. So there you go. I replaced that one capacitor. It's now properly biased to ground. It's already amplifying fine because that was never a problem. And you get fully working sound, and everything's fine. While I'm down in here, I might actually reflow some of these larger contacts because they used, it's not the worst stuff I've seen, but it's low quality solder. And for some of these high voltages, I think it'd be nice to have a little bit of reflow going on. So I might do a little bit of that. But no, it works. Anyway, hope that was helpful. How troubleshooting can work. You want to follow the circuit path and not just sort of willy-nilly change stuff out when you have no idea, you know. Oh, it's buzzing. Let me change the amp. No, there's a circuit path to follow, and I recommend opening up data sheets as often as possible to look at the parts and what the schematics are and what they're doing. And that's how I found out that capacitor was a ground bias capacitor. And of course, you know, I have some experience having some knowledge of, you know, various symptoms and heat and all that stuff, but, you know, how they affect electrolytics. So you won't have all that knowledge, but, you know, keep at this, doing this kind of work, and you will. And, yeah, hopefully you get some of these working. Don't just go changing capacitors all the time, folks. That's one last thing I'll say is, people nowadays have like this capacitor fetish. It's driving me crazy. I've been talking to people, and they just like, they'll have something that's totally working. They've never done a capacitor replacement before. They barely know their way around a soldering iron, and they're just like freaking out about how they have to replace all the capacitors. They're all going to leak. Oh my God. Please stop that, folks. Capacitor failures happen. There's a lot of other failures that happen though. And I have electronics that are 30 years old and work fine with all the original capacitors. People need to chill on the capacitor replacements. Yeah, obviously if it's a known problem with a known system where they're known to leak and cause damage, sure. But I also can't think of any piece of electronics that had leaking capacitors where they leaked even really badly, like in a Game Gear or something, where I haven't been able to clean it up and repair it. Like the damage is not always permanent. I'm sure it happens sometimes because the electrolyte can eat away those traces. But anyway, that's my little spiel about the capacitor fetish. I could do without it. There's lots of other things to troubleshoot in a circuit. So hopefully this video is helpful. Get your tube amp working. Don't buy one of these. It seems like pretty mid-range to lo-fi to me and overpriced. You're really paying for the heavy case and the metal around the tubes. But yeah, get one of those other smaller tube things. They're great. And if you can, of course, pay the big bucks to get a nice 200 volt, you know, tube preamp or whatever for a couple $100. Which honestly, for how much this costs, you could go that route, maybe even for the same price. That's it for this video. Segasonicfan, signing out. Just fix this tube amp. It's a hybrid tube amp and analog gain clone stage. Sounds so nice.